I've known Michael for a number of years, and I will have to say this, truthfully, and this is what's so wonderful about COFES, it was sitting next to Michael on a bus ride last year, out to the evening under the stars, where I really got to know him as a person. And I count him as a friend, one of my many good friends here at COFES. So please, I haven't been doing this morning, but help me give this guy a big warm welcome, huh?
Thank you. Well, I was up at 2:45 this morning because it's my normal East Coast wake-up time, and so by the time I got here at 8 o'clock, I was already starting to fade, but things got very hot very fast, and I'm wide awake now. I want to start with a pet peeve, which is that at most building industry conferences, not this one's an exception, we get to the point in the discussion that I call if only. If only building owners would lead the drive for innovation, we could solve all our problems. If only contractors weren't such assholes, we could solve all our problems. If only designers didn't have their heads tucked up their butts, we could solve all our problems. I want to change the premise of the discussion. This mess that we call a building industry is my responsibility. And it's my responsibility to do something about it and not point the finger at somebody else and say, oh, well, I could do a better job doing my job if only somebody else would do a better job. So I invite all of you to take that pledge and to figure out in your realm of work, however large or however small it is, that you endeavor to be part of the solution and not part of the problem. And because I have the microphone, I'm gonna challenge Jack's premise that a focus on the building as opposed to the transportation system is stupid or misallocation of resources. We could be sitting out in the parking lot right now because we don't really need a building to have this conversation, right? But if there's a focus, whatever realm that we're working in, again, if we're focusing on looking at issues systemically, but dealing with the issues that are right in front of us, we're going to move ahead and we're going to get better. 3 years ago, out of frustration, working for a large construction company and feeling like I was part of the problem and not part of the solution, I left and started my own company. And I'm focused on a very small piece of the problem, so Jack's going to have a problem with that, which is that one of those information drops, the information drop at construction handover. It's a very, very big problem. We've got a long way to go towards solving it. I'm currently chairing the COBE task group that stands for the Construction to Operations Building Information Exchange. It's a data schema to facilitate the exchange of information at construction handover. We should have had this problem solved a long time ago, but we don't. And we've made a lot of progress, and we're continuing to make progress on that. And my entire business model is built upon that, addressing that issue. So when I was putting this presentation together and thinking about what I do in terms of sustainability, I really thought I was coming from left field, and then Ken and Deke just totally set me up, so I feel like I'm on the pitcher's mound now. This is it. This is the whole problem statement. You can't improve what you don't measure, and you can't measure what you don't capture. Everything else I'm going to say is detail. So here's the basic value proposition for the built environment. When I talk about the built environment, I mean the building industry. Any entity that builds a building has a desire to turn that building into cash in one form or another. And buildings are the most illiquid asset that you can own. You can't trade it. You can't exchange it. Cash is the most liquid asset. And it doesn't matter if you're, what the goals of your organization are. At the bottom, the value proposition is turning that building into cash, generating revenue, supporting an enterprise, delivering value to the taxpayer, whatever it happens to be. That's the value proposition. And in order to convert buildings to cash, there are things that have to come in between. You have to turn buildings into information, and you have to turn information into time, cycle time. to take advantage of its cash generating potential. If you're not utilizing a building to its full potential, the amount of time that the building is being utilized is lower than it should be. So any building you look at, you can put into this equation. Deke's already said this. Buildings cost far more to operate than to design and build, and I don't even go all the way to the societal impacts. There's some data out there about it. It's not very good or very detailed. There was a study done by Fiatech years ago that for a typical commercial building, design and construction represents about 25% of the total life cycle cost, and operations represents 75%. For complex buildings, and by complex buildings I mean healthcare, biotech, laboratories, design and construction represents about 10% of the total life cycle cost, and operations represent 90%. Among my clients in healthcare, they tell me the number is low for the operational costs. That operation of the building over its useful life actually represents more than 90%. Now, if that is true, then even a very small savings in operational costs pays for the building. If you can save 11% of the operational costs of a complex facility over its useful life, you pay for the building. And anyone who's had any experience with how these facilities are managed knows that saving 11% is not difficult to do. The waste is much greater than that. Waste and inefficiency much greater than that. So what's the basic problem? It's a lack of information. Most building owners simply don't know enough about their buildings in order to be able to operate them effectively. And it's the classic example is if something has to be shut down to be serviced, the only way they know what parts of the building are going to be affected are to shut it down. It's hard to do operations and maintenance strategically that way. I had one client at a large hospital in Boston that estimated if they could strategically plan 15% of their regular preventative maintenance to take place during during business hours, they could save $2 million a year. And the reason, the head of facilities said, look, we have a lot of redundancy in our systems. We have backups, we have, particularly for life safety, there's redundancy, but even in the HVAC systems, if I have to shut down an air handler, I can boost the CFM on the air handlers in the surrounding areas. I can maintain a comfortable temperature, even if I have to shut down a zone. But because I don't know what happens when I shut something down, I have to schedule all my regular preventative maintenance after hours and on weekends, which is a premium on labor. That's a huge cost. So this is broken. We can't turn buildings into information, and we can fix it. The good news is we're creating all this information, and design and construction teams are delivering it. The problem is it's not being delivered in a format that's useful. And, this is an old cliche, right? At the end of the job, contractor backs up a truck. I don't show the photo of Lyle. Lyle's retired. But backs up a truck to the loading dock and dumps all the documents onto the loading dock, and we laugh and say it's a big joke. But now we're doing this instead. So there are a lot of design and construction teams that are very proudly, publicizing the fact that they deliver as-built building information models to their owners. And when I first started my business, I went and talked to some of those owners whose projects had been presented at case studies at industry conferences and asked them, what are you doing with your models that you received? And the reaction was uniform. Any guess? Laughter. Laughter.
Okay. You're using an interesting term, information.
Yes.
Would you consider those models as delivered to those owners information?
Yes, absolutely.
Why?
Because they're packed with data. They're packed with structured data.
They're packed with data, but there's a difference between data and information.
Okay. I'm not sure we have enough time for that, but we'll get to it.
I bring this up because what you're showing me right now, including the 90% statistic, I saw 30 years ago in Defense Department
Sure.
systems.
Yeah.
About the same thing.
Which is kind of depressing, isn't it?
Costs you a lot more than it is to design. And, it's the same problem all over again.
It is.
And it still hasn't been solved.
It hasn't been solved, but we have the tools to do that, to solve the problem now. So the crux of the issue here is that we're delivering information in a format that owners can't use. They have tools on their desktops that they've been using for years that fall under any number of initialisms, IWMS, CMMS, CAFLM. There are software tools that are designed to manage the workflow and the information that's needed to operate the building. And over here we have data that's being generated by design and construction applications, and those applications don't communicate with one another. So owners pay a lot of money for this information or this data and are unable to leverage it to operate their buildings. So the opportunity exists for building owners to be able to unlock that data. And part of the problem that we have in the industry is we tend to get caught up in dogma. And we have been talking for a long time about the life cycle building information model, in which this model is going to be kept, of the building is going to be kept up to date all the way through the building's useful life, and anytime it's renovated, it gets handed off to the next design and construction team, so on and so forth. It's a beautiful vision. It doesn't align with reality. We don't have an interface on the building information model that's suitable for operating and maintaining the building, for managing RPMs, regular preventative maintenance, for issuing work orders, and so on and so forth.
The attitude of it is not operational. The attitude
Right.
of that is, oh, this is cost accounting data, what happened in the past.
Right. And so the current state of the art, we've got great tools for design and construction, we've got great tools for operations and maintenance, and those tools don't communicate with one another. And as an industry, on the design and construction side, we've been kind of pushing this model uphill. And being an apostate, I decided, okay, the data's there. It's there and available for harvest. And the data's needed over here. So I just have to get it from here to there. Now, in that workflow, the life cycle building information model isn't being maintained always, right? Because the owner may not have the ability to manage model data. But the owner can leverage that data now. So let's solve that problem now. And as the state of the art advances and the tools evolve so that we can integrate the model data with the operations and maintenance data, we'll get there. But in the meantime, let's solve the business problem. There's no such thing as an original idea. My insight is not unique. There are other people who are doing it. There's going to be a case study published in June in the National Institute of Building Sciences Journal that was done by Christine Fallon and Associates in Chicago on a very large campus in which they successfully did this. And I'm reading the case study, and I'm thinking, damn, I wish that was my case study. So there's nothing unique about this insight. So this is the desired outcome today. This is what we can accomplish today with the tools that we have. Owners should be able to receive the building information they need to manage and operate their building on the first day of occupancy. Typically, when they receive a deliverable at the end of construction, whether it's an as-built model or it's all of that data in some other form, a typical owner takes 18 to 24 months to re-enter that data into their facility management system. The cost of that rekeying is inconsequential. It's substantial, but it's inconsequential. The real cost is not being able to maintain the building properly for 18 to 24 months and looking stupid in front of the people they serve. because they can't change a light bulb, literally can't change a light bulb. So that was one of our promises in our business model. And the data's got to get into the software that they're using. Almost all of them, all building owners already have software in place, and they're making very poor use of it. And they often have a hard time justifying the licensing costs of their systems. So part of our premise is we're going to help you maximize the value of the investment you've already made. And again, this is apostasy, but they shouldn't have to develop proficiency in new tools if they don't want to. Because the data's there and they have the tools to use it, so we should be able to get that data into the tool that they want to use. Always, always, always looking for the opportunity to push them further in terms of the state of the art, but not if they're not ready to go there. So here are the basic elements. The technology's there. This is not a technology problem. It's a business process problem. And daily, we deal with people who are either reluctant to share information. The whole liability issue, that's kind of gone away. They think it's going to take them time. Or they're creating data, and they don't even realize it. We had a project meeting last week. We're talking to the modeler for the major MEP sub on a large healthcare project, and we're asking him whether 8 parameters or 8 attributes of the equipment are available in their authoring software. He goes, oh, we never look at that because we don't need that data for construction. The only data they're interested in is the CNC data that they can use for fabrication. But the object name and manufacturer model number, you know, they don't look at those fields. So I said, well, can we look at it? I didn't even, you know, that particular individual didn't even know how to look at the parameters, but he figured it out in about 5 minutes. It was all there. It was all there. So somebody working for him in the process of modeling, not because they were directed to do so, was populating the data fields. We find that happening over and over and over again, so we're always trying to turn rocks over and see what's under them and take it and leverage it. Now, ultimately, we would be in front of the train and providing the data specification before design and construction begins so that the model data gets constructed and formatted in such a way that it can be exported properly. This is the problem. An institutionalized business process for information stewardship and exchange. And I see John nodding his head, and we were talking about it earlier. We are all in the business of creating information. We don't own that information. We are stewards of that information. Stewardship is a responsibility to convey to your successors that which you have received in a form that is better than you received it. In other words, you are responsible for taking care of something that is given to you and then handing it to someone else in better condition than you received it. And that's a mindset more than anything else. And that commitment has tremendous value because now that information becomes far richer, more accurate, more intelligent. So this is another pet peeve of mine because at industry conferences, again, not this one, building industry conferences, we'll have presentations on big data, and it's, you know, again, the holy grail, like the life cycle building information model, big data is going to solve all our problems. Well, I've spent some time educating myself about big data and I'm taking a course at Johns Hopkins in data science, studying R programming and a lot of other fun things. And there are differences. There are 3 characteristics of big data. Large volume, measured in, you know, hundreds of thousands or millions of data points, depending on what type of data you're talking about. The data comes in very fast. And the variety of the data types, and by data types I mean data formats, tends to be pretty limited. So For example, on your cell phone, if you have mapping app and that gives you traffic data, they're not actually looking at the number of cars on the highway. They're looking at the density of cell phones. And that's not perfect. It's imperfect, but it's good enough. But it's, you know, they're collecting hundreds of thousands or millions of data points, and they're making an assumption, okay, there's one cell phone per car. And part of the reason there's a backup is because people are looking at the cell phone instead of looking at the car in front of them. And there may be 2 or 3 cell phones per car, but we can adjust for that. So, but the variety of information that's coming in, or the data types, are very limited. And if you're looking at you know, social media data, you know, tweets, images people are posting to Facebook, okay, so there's 2 different data types. And then you can have chatter on Instagram, whatever. That's another data type. But again, very, very limited in terms of its data types. Hello. Now, if we compare that to building data, the volume of building data, even though we think of it as overwhelming, is actually very small, several orders of magnitude smaller than what we would consider big data. Not so fast. You know, when we're looking at big data, it's coming in instantaneously or in seconds or minutes or milliseconds. Building data, 2 years. There's a difference there on a particular project. The variety of data, both in terms of data types, data formats, is high, much higher with building information. And if you look at the content level, it's much, much higher. So for example, on a typical healthcare project, we're tracking 228 different types of equipment. There are a total of about 15,000 instances. So, but that ratio, 228 to 15,000, it's not that far off. Whereas with big data, you'd be looking at 4 data types, hundreds of thousands or millions of data points. Very, very different type of data. The other thing that's completely missing, or not considered as an attribute of big data, is granularity. There's very little granularity typically when you're looking at big data. And I challenge anyone to, you know, give me an example that contradicts that. I mean, even if you're looking at epidemiological data, which is one of the first disciplines to apply the concepts of big data. And I would argue that, you know, big data came out of epidemiology. So you look at a population, and you look at the geography of where they live, and then you ask them a series of questions about their health status, and you discover that there's a cluster, a cancer cluster over here. And if your survey sample is large enough, you can establish a correlation between their geographical location and the incidence of cancer. And then you can ask yourself, why? Now, there's no causation. You don't know why. But that correlation is very powerful. And you can start to look what's in the water, what's in the soil, what are they eating. And that data is very valuable. But there's not a lot of granularity there. You're looking at relatively small number of attributes or parameters, geographical location, 10 health questions, you know, and then your population size or population characteristics, demographics. Building data, the granularity is off the charts. And the reason I'm bringing this up is because to solve these problems of being able to efficiently and accurately compile building information and exercise stewardship of it throughout the building's useful life, you have to get into the weeds. You have to be willing to get into the weeds. You need to always have the strategic vision and the recognition that I'm not the center of the universe, that the data I produce is valuable to someone else. So you have to understand that you're part of a supply chain, but the data that's in front of you, you've got to look at a very high level of specificity and detail. Component name, manufacturer, model number, serial number. It's boring. I'm fond of saying that the work we do is highly detailed, highly tedious, highly important. And so when I'm looking for people to help us with this, I'm looking for people with degrees in library sciences. People who care about information at a detailed level and yet understand that there's a data structure or schema that it has to fall into.
Since you're talking about library science and stewardship of information, you're talking about managing the since you're talking about library science and stewardship of information and management of the individual information quanta, I would argue that what your library science people are going to bring to you is something that's going to solve the problem in an entirely different way, which is not, here's the data and it's accurate, it's findability and navigation. The problem is not, do I have the data? It's how do I find the proper data that I'm looking for? Okay, we got tons of data, but somebody at the other end of the building can't find it because it's not organized or categorized in a way that's in your ontological system.
Precisely.
What's your thoughts on things like machine learning and deep learning in this? So you get the data. What are things in this space that need to be better understood from that data where it isn't a manual process of churning through the data?
A lot of these processes can be automated. And, one of the things I appreciate from, what little education I have in data science is the power of those tools for data mining and querying and so forth. In terms of machine learning, either machines have to get a lot smarter or I have to get a lot smarter. There are so many value judgments that have to be made that there's still a very high quotient of professional judgment that has to be exercised, at least as the data is being compiled or organized the first time. Once it's structured, then if it's properly structured, it's much easier to use machine learning, to understand or amplify that data. I don't know if that helps or answers your question, but I haven't gotten quite that far yet.
Peter, in just a second. I certainly want to amplify what you've been saying, because on this airport project, this is exactly what the client is doing to us. They want all of this information stuffed into BIM models. We're spending an amazing amount of time specifying that. I doubt if they will be able to use it.
That's right.
Quite frankly, you said a very good point about taking responsibility ourselves for our own problems, because I find myself getting ready to say, well, if only Autodesk would do a better job at that interface into Revit.
I forgot to mention software.
Yeah, sorry about that.
Only.
Peter, please.
So I'm wondering if there's an analogy to the product world that I come from. So products have gone through this problem of there is no user manual, and then it's a crappy user manual. And it sounds you're kind of at the stage of, boy, if we only had all the data in a file cabinet, that would be a step forward. But the progress in products is, first you do research on the problems people have. I mean, the ideal building would be self-explanatory. It wouldn't require a manual. And so the steps you find for a building is, like most people, when they come into a room like this, they can't turn on the lights because they can't figure it out. Well, that should be self-explanatory. And you find through that kind of ergonomic research, what are the problems building owners have the building self-explanatory, where you need to go further, maybe you put a barcode that gets you to the web site for the building. So I mean, I just think there's maybe a paradigm shift that's needed in how you think about building information systems to buildings that are self-explanatory. And I realize that's difficult because a product might be made in a million quantity and buildings are unique, but the furnaces and the lighting systems and things like that are replicated. So anyhow, just a thought there. And the other, just a quick thing, if you want another example of big data that's granular, just Walmart has like maybe 50,000 SKUs, so there are examples.
Yes,
so,
I would agree
So I
with
just
that.
don't want you to get caught in that, and the next time you go out there.
I think we've got a question up here from Jack. I'll bring it back to you.
I think you're telling me that people who deal with buildings are different than people who deal with other systems. When designing other systems, we start with the question of who's going to use this thing and how does it serve them? So it seems to me when you're designing a building, your first question is going to be who's going to use it and how can it serve them? And your first answer ought to be the building manager who's faced with maintenance and evolution. And then you design the building to produce what that person needs. And you evolve that model and keep it alive for the next N years. The actual building itself is simply a fallibility test on whether or not your model's complete.
But I would argue the premise is that there's a single end user and who has a specific set of needs. There are so many end users, and there's so many end users in the process. And I think designers are very good about thinking about the occupants. How will the occupants use the building? How will they move about the building? How will the spaces serve the activities that are going to take place in the building? I think designers are actually very good at that. But there are other stakeholders. There are the building manager, facility manager, and we're uncovering that all the time, And in a hospital, who are the most important people? Nurses. And you really need to listen to them and understand their business process, and it can come down to how you number the rooms, whether they can, request the services they need appropriately. I don't want to take up too much time.
John?
Yeah, I would argue that the patients are actually the more important ones.
I meant among staff.
In response to what Jack was saying about, you should always look at the end result first, right? But that's common sense for a lot of folks, maybe not for everyone. But the technology itself has been sporadic throughout the supply chain, and I think we're only getting to the point to where the technology and all the information flow can actually get us to a point where we can start asking those questions about our owners and what are their end uses and what are these systems, because the technology has been developed throughout the supply chain at varying rates, and the information exchange just hasn't been there. It's starting to get better, but it's still not quite there yet. So always asking what is the end goal, we were never quite able to cross all of those bridges to get to that end goal.
Right.
I'll disagree with you. It's not about the technology. Okay? The problem we're seeing in building industry, you saw in manufacturing, okay? And everybody said, well, who's the most important person in hospital? Who is the most important person in the manufacturing enterprise? It wasn't the engineer who designed the thing. It's the manufacturing engineer who says, here's how we're going to build that thing that you came up with. And that wasn't the most important person. It was the end user who was going to buy the plane and said, I have to operate this. Mm-hmm. The cost model you show, okay, well, you can see cartoons way back, in the 50s and 60s showing, well, here's what it costs to manufacture and here's what it costs the government to operate. Mm-hmm. This big, huge iceberg all the time. So it's really having that system view of saying the problem is bigger than me just being able to cut that chip. It's how that chip was designed, how it was produced, how it's going to be supported. All of those decisions looked at from a larger context is the problem. And we are still not thinking about that. We're thinking about, oh, I got to move my widget from here to here. And that's all I worry about, not that bigger problem.
Mm-hmm. We have a question from Nathaniel behind you. And Stephen, I'd like you to come up here and we'll start getting you set up. And I said we were going to sort of have a short bio break. I would like to suggest to you that we'll continue this conversation, and this would be a good time if you do feel a need to stand up, stretch your legs, and find the restroom outside.
So when I'm building a satellite, I work closely with my systems engineer, and I can't put him in the front of the room. And so Jack says, what's the most important question? And Brian says, well, if you incorrectly say that navigation's the most important, or the instrument's the most important, or the power system's the most important. You want to talk about your 4 dimensions of volume, velocity, variety, and granularity. They're all there. Mm-hmm. What is happening in buildings with allowing data models to self-assemble and allowing the self-assembly of teams down in the down in the bowels, putting their data together in a way that makes sense for them, in a way that's exportable.
What is happening?
Yeah.
Nothing.
Okay. That's my question.
Sorry.